Did you know that an artificial intelligence can now identify a safe landing zone on Mars faster than an entire team of human experts? This isn't science fiction. It's the reality of space exploration today. On October 21st, 2025, artificial intelligence, a sophisticated set of computational tools that allow computers to learn, recognize patterns, and make decisions, has moved far beyond the confines of our smartphones and smart homes. It is now fundamentally reshaping humanity's grandest adventure, our journey into the cosmos. The change is not on the horizon. It is here, happening right now, quietly and profoundly, altering how we design, navigate, and understand the universe around us. This shift is bold, it is exciting, and its implications are very, very real. You should care because space exploration, for all its majesty, is fraught with immense cost and monumental risk. Every ounce of mass, every joule of energy, and every second of an astronaut's time is meticulously accounted for. In this high-stakes environment, even small gains in efficiency can mean colossal savings and higher chances of success. The first major arena where AI is making an indelible mark is in the conception and design of our tools for space exploration. Crafting a new satellite, a powerful rocket, a resilient interplanetary probe is a process that traditionally takes years, sometimes decades. It involves countless hours of engineering, complex simulations, and painstaking trial and error. Engineers must balance weight, strength, fuel efficiency, thermal resistance, and cost. An AI can navigate this labyrinthine design space with astonishing speed and creativity. Using generative design, a computer is given goals and constraints, then explores thousands or even millions of potential designs. This computational prowess discovers novel solutions that might never occur to a human designer. Intricate, organic-looking structures optimize for minimal weight and maximum strength, often mimicking nature. Beyond components, AI plans missions, calculating fuel-efficient trajectories and gravity assists to save propellant and extend mission life. It meticulously schedules power usage to keep batteries charged through light and shadow. NASA uses AI to design lightweight structural components, adding material only where structurally necessary. The resulting parts look skeletal and strange, yet can be up to 30% lighter while just as strong. The second profound application of AI is granting autonomy to our robotic explorers. On average, Mars is 225 million kilometers away. Signals take 5 to 20 minutes one way. Real-time control is impossible. AI becomes a necessity for survival. The rover must be able to think for itself. Using cameras and sensors, the AI builds a 3D terrain map and flags hazards, rocks, steep inclines, soft sand, treacherous craters. Based on programming and experience, it plots a safe, efficient path, autonomous navigation, or AutoNav. Each day, teams uplink high-level goals. The rover handles the details, covering more ground and doing more science. AI enables rapid targeting, identifying a rock of interest and aiming laser or drill precisely. The challenge is mistakes in novel environments. AI is only as good as its training. Shadows misread as holes, or unseen hazards missed. Engineers mitigate with years of simulation and a strong self-preservation bias. When uncertain, stop and wait for human oversight. Result: massive increases in scientific return, hundreds of meters per sol while collecting images and data along the way. Space is speaking to us, but it does so in a language of overwhelming data, and AI becomes our universal translator. Modern telescopes, on the ground and in orbit, generate a fire hose of information every night. The Vera C. Rubin Observatory will capture more data in weeks than Hubble did in decades. Images, spectral readings, radio signals, far too vast for humans to inspect manually. AI scans colossal datasets at incredible speeds, flagging faint anomalies that may signal discovery. Periodic dimming can hint at an exoplanet transit. Transient flashes, supernovae, even neutron star collisions. AI also cleans data, removing noise, correcting for atmosphere, sharpening details. Kepler shows the payoff. AI found exoplanets missed before, including the 8-planet Kepler-90 system. Benefit: accelerated discovery. Challenge: false positives, glitches, cosmic rays, noise. The solution? AI filters first, humans verify. Beyond designing missions and driving rovers, AI is being developed to support and protect human astronauts. Astronauts are explorers, scientists, mechanics, doctors, janitors, living in a confined, high-stress environment. AI is emerging as a critical companion, monitoring health, managing systems, reducing cognitive load. Wearable sensors track heart rate, respiration, body temperature, and sleep patterns. AI looks for subtle deviations from baseline, early signs of illness, fatigue, or stress, alerting crew and mission control. A tangible example is Simon on the ISS, understanding voice commands, displaying procedures, even sensing emotional tone. Benefit: practical assistance and companionship, vital on long, lonely journeys. Challenge: systems must be reliable, secure, and helpful, not intrusive, and work perfectly if cut off from Earth. For Mars, onboard AI must lead diagnostics in emergencies. Trust is built through extensive training and flawless performance. The goal: a calm, competent guardian that keeps astronauts focused on exploration and science. While the promise is immense, we must proceed with clear eyes about limitations and risks. AI depends on high-quality, abundant data, scarce in space. Bad data yields bad decisions, which can be catastrophic. The black box problem: deep models can be opaque. If AI fires thrusters, controllers must know why. AI can struggle with truly novel conditions. Space is the ultimate edge case. Mitigate with richer simulations and diverse training data. Develop explainable AI to articulate reasoning in human terms. Design with redundancies and fail-safes. Keep a human in the loop for mission-critical actions. We don't need perfection, just resilient, trustworthy systems where machine intelligence and human judgment complement each other. AI is a present-day reality, an engine of progress. It helps us design lighter, stronger, more efficient spacecraft. It sits at the helm of Rovers, granting unprecedented autonomy. It is our tireless partner, sifting cosmic data to reveal hidden secrets. And it is being developed as a guardian for those who brave the void. Soon, smarter telescopes will identify events in real time, alerting observatories worldwide. Rovers will plan an entire week of investigation on their own. Long-term AI may manage life support, power grids, and food production for self-sustaining bases. As always, space tech transforms life on Earth and inspires the next generation to ask big questions.